Good morning, Ron. How are you?
I'm doing great. How you doing?
I'm doing well. So tell us a little bit about yourself. What is your background to bring you to this spot dealing with the National Freshwater Foundation?
Well, I'm a mechanical engineer out of UMaine, and when I went to Denver University and got an advanced degree, I studied environmentalism, communications, and loved the outdoor nature of the Smoky Mountain National Park and the other national parks, and I really like outdoors and nature.
All right. So you founded this thing that is called the National Freshwater Foundation. Tell me something about that. What is it?
Well, the National Freshwater Foundation is a nonprofit organization. It promotes the National Smart Water Grid. The National Smart Water Grid is designed to capture water at the river, which could be the Mississippi River, the Missouri River, or other tributaries, during flooding. It transports the flood water away from those rivers, helps the Army Corps of Engineers have another tool that they could use to manage the river. And then we want to transport the water away to the western states so it could be used as a new freshwater resource for the southwestern states.
All right. And why? Why would I even be concerned with what's happening in the western states?
Well, you may or may not, but there's several states out west that are experiencing decades-long drought, and that trend is likely to continue. There's also demographics where people are moving to the west. Some of our heavy industry is there. So a significant future is in the west, but they need water to support their people and their industry and their agriculture.
Okay. So you said it pumps floodwaters. What's the purpose of pumping those floodwaters?
Okay. Well, first of all, for environmentalism in the foundation, we have a policy of do no harm. So I don't want to interrupt capturing water below flood stage, where 40 million people get their water supply from the Mississippi River. So if we only capture water above flood stage, then we're not interrupting the current supply, and we would then be taking this flood water, which can cause incredible damage. And floods are the number one natural phenomenon that causes death. People drowning from flash floods or all kinds of different floods. So if we can capture the flood water, we're going to save water, save lives.
Oh, save lives. And you said it's on the Mississippi. Could it work anywhere else?
It can. So for example, these rivers that are the tributaries to the Mississippi River, example being Missouri, it could be applied outside the city of Kansas City. Kansas City has a 50-foot high levee protecting the city. If that levee broke, Kansas City would be flooded. It would be a horrible thing. And in the past, the water has gone up to 48.5 feet. People have gone out on that levee. It's scary when the water's that high and it's got wave action in it. So if we could capture the water during flood events at Kansas City on the Missouri River and send it west to the Great American Desert in between Colorado and Kansas, we would help out that whole region. We'd help out the farmers that currently spend a lot of money for irrigation of their farms, but if they had a very significant freshwater resource, so we could send a pipeline adjacent to I-70 from Kansas City, head to Denver.
So do you already have the right-of-ways for this?
No, I don't have the right-of-ways.
So what is your approach?
Okay. The first approach was to have a conceptual design, and then second approach is to see if it's feasible, because if it isn't feasible, it doesn't make sense to do it. But I wrote the conceptual design and wrote a feasibility study, pitched the idea at Congress at a water policy event, and they liked the idea, but they gave me big institutions to work with such that I could polish the idea. So the conceptual design and feasibility study was reviewed and edited, commented on, by Lawrence Livermore National Lab and the Southern Nevada Water Authority. And in putting those information into the Smart Water Grid book, we now have something that has a conceptual design and is feasible.
All right. I can tell you're very passionate about what you've done. Tell me a little bit about how you arrived at this solution.
Okay. Well, in the 90s and 2000s, I worked in emergency management, preparing emergency management hazard assessments and looking at natural phenomena and disasters, and also worked with incident command and, you know, helping, first of all, prevent disasters, but when they actually happen, how to save as many lives as we can during the disasters. I was very much involved in New Orleans after these big hurricanes of Katrina and Rita, because I was working as a nuclear safety analyst, as a emergency preparedness, as a mechanical engineer for the Department of Energy. And the manager of the Strategic Petroleum Reserve said, "Ron, come down here, we need your help, we need your expertise." So I came down here to New Orleans and was asked to evaluate 100 years of hurricanes hitting the Gulf Coast and what is the impacts of those? What can we do about it? And I was also asked to evaluate the levees along the Mississippi River here in New Orleans. Now there's a lot of damage being done as a result of multiple hurricanes, but Katrina and Rita really ravaged the area of New Orleans. So I was asked to evaluate what could we do about it. There was lots of details there, but I was living in Nevada at the time, and that's the Mojave Desert. And then I'm coming out here and seeing the floods and flying back and forth over the country and seeing, geez, we could actually take floodwaters before it does the damage, help New Orleans, help lots of areas along the Mississippi River, if we can capture the water before it does all this damage. Well, what would you do with it? You have to divert it away from the Mississippi River. So where would we put it? Let's send it to where we really need that water. And so there's thousands of miles of pipeline across the country, and a lot of them are hazardous material for oil and gas, and we need those. Why not have a water pipeline from the Mississippi River all the way to the western states? Take it from the Mississippi River Basin and put it in the Colorado River Basin. It has to cross the Continental Divide, so, well, is that hard? It sure could be, but the Alaskan pipeline is a good model to use. It goes from the north slope of Alaska to the south slope of Alaska. It's about 1,000 miles. It has to go up over a mountain range. So when they designed that, they thought of 12 pumping stations that might be needed. They really only need 9 pumping stations. And if we use pipes and pumps that are already in service in the country, at least those designs, we'd have to build them. We're not taking them out. But we could use pipes and pumps, for example, that are used in the California Aqueduct at the Wind Gap Station north of Los Angeles. Those pumps are designed at 282,000 gallons per minute, and they pump water 565 feet high, and they could pump through 12-foot diameter pipes. So let's say we took 4 of those pumps in parallel, 4 12-foot diameter pipes. We could pump 1.1 million gallons of water per minute, 1.1 plus billion gallons per day. And a flood event on the Mississippi River might last 30, 60, 90, 120 days. So just to capture flood water on the Mississippi River, we could capture billions of gallons of water per day, put it in pipelines and send it west.
So Ron, you're throwing a lot of numbers at us. What does those numbers mean? I mean, you use these big numbers. Can you tell me, for just me, what does that look like? What do those numbers look like when you talk about all this water that you can pump? What does it look like?
Okay, well, essentially, in short, it would transform the country.